The map was built to make the universe clearer. Instead, the clearer it became, the harder it was to make everything agree. Nothing looked wrong. No galaxies vanished. No impossible structures appeared. Fly through the finished map, and every cluster, filament, and empty region would seem exactly where it belonged. The problem appeared only when millions of observations became one picture. That picture began in the mountains of southern Arizona. Night falls over Kitt Peak. The dome of the Mayall telescope opens, and 5,000 tiny robots turn toward the sky. Each robot controls a single optical fiber. Each fiber locks onto one carefully chosen galaxy or distant quasar. Within minutes, thousands of targets are ready. Then the telescope waits for their light. Some of that light has been traveling for billions of years. Each photon carries a fragment of information. Alone, it tells us almost nothing. The exposure ends. The robots turn again. New galaxies replace the old ones, and the process begins again. Night after night, month after month, year after year. The measurements accumulate. At first, they are scattered points. Then the points connect. Clusters of galaxies emerge. Long filaments stretch between them. Vast empty regions appear where almost nothing exists. The map grows and keeps growing. Eventually, it becomes the largest three-dimensional map of the universe ever assembled. More than 6 million galaxies and quasars. Nearly 11 billion years of cosmic history. Every point began as real light reaching Earth. Nothing was imagined. Nothing was drawn into place. The map exists because the universe placed every galaxy there long before anyone tried to measure it. From a distance, the pattern looks like a web. Dense clusters anchor long strands of galaxies. Between those strands lie enormous voids where matter is scarce. The same structure repeats across distances almost impossible to picture. But the map preserves more than the location of galaxies. It also carries the trace of something much older. Before galaxies existed, tiny ripples moved through the young universe. As space expanded, those ripples left a recognizable spacing in the way matter spread out. Billions of years later, that spacing still survives in the distribution of galaxies. Measure it nearby. Measure it again much farther away. Compare it across different periods of cosmic history, and the changing scale reveals how the universe expanded over time. That was the real purpose of the map. Not just to show where galaxies are, but to reconstruct the history of cosmic expansion with greater precision than ever before. The uncertainty fell below 1%. Nothing like this had existed. And that was when the measurements stopped fitting together as neatly as expected. The difference was far too small to see in one galaxy. No photograph could reveal it. No single observation looked unusual. Only after millions of measurements were combined did the pattern appear. More observations were added. The mismatch remained. The uncertainty shrank. The mismatch remained. The map became more precise. The mismatch remained. Nothing inside the map had moved. The galaxies stayed where they were. The filaments did not shift. The voids remained exactly where gravity had left them. Every new galaxy made the map more complete. Together, they changed what the map seemed to mean. The map never contradicted itself. It simply refused to tell the story everyone expected. And it could not explain why. A map can show where galaxies are. It can show how they are arranged across space. It cannot tell us whether the story we read from that arrangement belongs to the universe itself. or only to the way the map was being interpreted? To find out, the map had to be placed beside another picture. Not another map. Something much older. Long before the first stars ignited, before the first galaxies began to gather, the universe was filled with an intense glow. As space expanded, that light cooled. Today, it survives as a faint background spread across the entire sky. It looks nothing like the cosmic web. There are no clusters, no filaments, no enormous voids. Only tiny variations scattered across ancient light. They're so small that they disappear without specialized instruments. Yet those faint patterns preserve a snapshot of the universe when it was less than 400,000 years old. The contrast could hardly be greater. One picture is built from millions of galaxies spread across billions of light years. The other is light that has been traveling toward us for nearly the entire age of the universe. One shows the cosmos today, the other preserves it near the beginning. Almost 14 billion years separate them. The same expanding universe connects them. If the mismatch came only from the galaxy map, placing these two pictures together should have made it disappear. It didn't. The broad story still held. The ancient light naturally grew into the vast network of galaxies revealed by the map. Most of the universe's history lined up remarkably well. Only one part refused to fit perfectly. The map offered no explanation. It simply stayed the same. Then a third picture entered the comparison. Across distant galaxies, certain stars end their lives in explosions bright enough to outshine the galaxies around them. For a short time, they become visible across enormous distances. Because many of these explosions reach nearly the same true brightness, astronomers can use them as cosmic distance markers. Now the universe could be measured in two completely different ways. The galaxy map measured structure. These stellar explosions measured distance. If both described exactly the same expansion history, the remaining mismatch should have faded away. Sometimes it nearly did. Sometimes it didn't. One of the largest collections of these exploding stars, Pantheon Plus, remained broadly consistent with the familiar picture of the universe. The tension eased. Another collection, known as Union 3, leaned in a different direction. The tension grew stronger. A third dataset from the Dark Energy Survey pointed much the same way. The universe had not changed. Only the observations being compared had. None erased the galaxy map. None contradicted it. Each only changed how comfortably that same map fit beside another picture. Picture several transparent maps of the same coastline laid across a table. One came from satellites, another from aircraft, another from ships approaching the shore. Almost everywhere, they overlap. Then one stretch slowly drifts away. Not enough to redraw the coastline, just enough that your attention keeps returning to the same place. You don't know which map is responsible. You only know they no longer sit perfectly on top of one another. That is what these observations began to resemble. The galaxy map never changed. The ancient light never changed. The exploding stars never changed. Only the space between those pictures became harder to ignore. No single observation told the whole story. Only when they were viewed together did their meaning begin to shift. The map had not become less complete. It had become harder to place inside one perfectly consistent picture of the universe. Without changing a single galaxy, it began to mean something different. The observations stayed the same. Our reading of them did not. For years, that picture rested on a simple idea. As the universe expanded, the force driving that expansion never changed. Galaxies evolved. Stars were born and died. Space itself kept growing. But the influence behind that growth was assumed to stay constant. It was an elegant idea. More importantly, it matched an extraordinary range of observations. For a long time, every new measurement only seemed to reinforce it. The new galaxy map did not suddenly overturn that picture. It simply became harder to make every observation fit inside it at the same time. That distinction matters. A scientific model isn't judged by how well it explains one measurement. It's judged by whether completely different measurements continue telling the same story. The galaxy map measured the universe's largest structures. The ancient background light preserved conditions near the beginning of cosmic history. The exploding stars measured distances across billions of years. 3 different methods. 3 different windows into the same universe. As long as those windows overlapped, confidence naturally grew. If one drifted away, the simplest explanation was usually a measurement error. But that wasn't what these comparisons showed. Most of the picture still overlapped. Only one region refused to settle. The disagreement remained small. It also refused to disappear. Some combinations of observations made it easier to see. Others softened it. None erased it completely. That was why the familiar picture survived. The evidence wouldn't let scientists abandon it. But it wouldn't let them ignore the mismatch either. Compare the galaxy map with one collection of stellar explosions, and the traditional model still fits comfortably. Compare that same map with another collection, and the preference shifts slightly away from it. Neither comparison is obviously wrong. Neither is complete enough to settle the question alone. The difference between them becomes part of the evidence. The map never changes. Only the picture surrounding it does. Think about hearing the same song through different speakers. The melody never changes. Almost every note sounds identical. Only one quiet passage seems slightly different depending on which speaker you're using. You don't assume the music has changed. You listen again. Then through another speaker, then another. The melody survives every test. So does that faint difference? That is where the universe now seems to stand. The broad picture still holds together. Galaxies still weave the same immense cosmic web. The oldest light still carries the imprint of the early universe. The stellar explosions still trace an expanding cosmos. None of these observations contradicts the others. They simply no longer overlap as effortlessly as they once did. The question is no longer whether the map is right. Every new observation has only made it more precise. The question is whether the picture built around that map is as complete as we believed. No single observation can answer that. Each one only narrows the space where the answer might eventually be found. The universe hasn't become more mysterious. Our measurements have become more precise than the picture we've been using to explain them. And as that precision improves, the number of possible explanations doesn't grow. It shrinks. A better map doesn't create more realities. It quietly eliminates them, one by one. One possibility was obvious. Maybe the mismatch came from the map itself. Perhaps something subtle had slipped into the observations. Maybe the galaxies had been selected in a way that introduced a tiny bias. Maybe one part of the measurement had drifted so slightly that no one noticed at first. Those questions had to be asked. Every survey this large creates countless opportunities for tiny errors to accumulate. Millions of observations pass through calibration, atmospheric corrections, software pipelines, and statistical tests before they become a finished map. Small imperfections are expected. Big conclusions are not. So the map was tested again. Different regions of the sky, different slices of cosmic history, different analysis methods. The result barely changed. The pattern held. Attention shifted elsewhere. Perhaps the map wasn't the source of the mismatch at all. Perhaps the tension came from the pictures surrounding it. Take the exploding stars. They were never measured by one telescope or one observing program. Their record spans decades. Different teams, different instruments, different observing conditions. Bringing all of those measurements together is an achievement on its own. It also leaves room for tiny differences to survive. A slight calibration offset, dust inside distant galaxies, changing the light before it reaches Earth. Small differences in the environments where those stars exploded. Even the way those effects are corrected can ripple across measurements stretching billions of light years. That is why two collections built from the same kind of observation do not always produce exactly the same result. The galaxy map never changed. The datasets around it did. Some comparisons left almost no visible tension. Others made it harder to ignore. Neither erased the other. Both became part of the evidence. That is why no single comparison has become the final word. Every new observation has to fit beside every observation that came before it. The picture has to work as a whole, not one section at a time. So the map remains exactly where it has always been. Millions of galaxies tracing the largest structures ever measured. The ancient background light remains where it has always been. A record from the earliest observable universe. The exploding stars remain where they have always been. Brief flashes marking immense cosmic distances. None of these observations demands a different universe. None proves the familiar picture is incomplete. Together, they simply leave less room than they once did. That is where the story stands today. Not between certainty and doubt. Between two pictures that still resemble one another far more than they differ. One remains slightly easier to draw. The other fits a little more comfortably where some of the observations overlap. Neither has earned the right to replace the other. So the universe keeps doing what it has always done. It offers another night of observations, another galaxy, another measurement, another small piece of a picture that is still teaching us how to read it. The next answer will not come from a clever equation. It will come from another map. In fact, that map is already taking shape. Every clear night adds more galaxies, more quasars, more distance measurements spread across the expanding universe. The same cosmic web is being traced again with even greater precision. If the remaining mismatch slowly fades, the familiar picture of the universe will grow stronger. If it becomes more consistent instead, the picture itself may have to change. The observations decide. Nothing else does. And the galaxy survey is no longer working alone. Far above Earth, the Euclid spacecraft is building its own map of the large-scale universe from space, beyond the blurring effects of the atmosphere. On a mountaintop in Chile, the Vera C. Rubin Observatory is preparing to watch the southern sky again and again. Not once. Not twice. Hundreds of times. Each pass adds another layer to an enormous record of the changing universe. None of these observatories was built to defend an existing idea. None was built to overthrow one. They were built for the same reason every map has ever been made: to replace guesses with measurements. That is what makes the next generation of observations different. Every new measurement now carries two equally valuable possibilities. It may shrink the remaining disagreement, or it may strengthen it. Either outcome moves our understanding forward. For decades, greater precision mostly meant confirmation. Better instruments refine numbers we already expected to see. Now precision is doing something else. It is becoming sharp enough to expose the places where the picture itself may still be incomplete. That is not a failure of science. It is one of its oldest patterns. The more clearly we observe reality, the less often reality matches our first explanation. The map before us is still the largest three-dimensional portrait of the universe ever assembled. Its galaxies have not moved. Its filaments still span unimaginable distances. Its vast, empty regions remain exactly where gravity left them. Nothing visible has changed since the first time we looked at it. Only the way we read it has changed. At first, it looked like the strongest confirmation yet of a familiar story. Then another measurement was placed beside it. Then another. Then another. The map never argued with any of them. It simply refused to agree perfectly with all of them at once. That is where it stands today. Not as proof that our understanding of the universe is wrong. Not as proof that a new idea is right. Simply as the most complete record we have ever assembled of a universe that is still revealing itself. Every new galaxy will be added to this map. None of them will change the picture on its own. Together, they may change what the picture means.